All right, so we're going to do a little work with Pythagorean theorem today. And Pythagorean theorem, we're going to introduce it today. We're going to be using it pretty much all throughout the whole year, the whole course. We're going to come back to Pythagorean theorem and learn more about it a little bit later. But for right now, we're going to show how Pythagorean theorem is sort of connected to what we were doing with our distance formula. And that's why we're talking about it now. So over here on the right, let's put a coordinate plane on there, and let's say we have a segment. So using distance formula, we would identify the ordered pairs, and then we would plug it into our distance formula. y2 minus y1, x2 minus x1. Effectively, what that did was give us the rise and the run. So if we think about our distance formula, we have our x2 minus x1 squared, y2 minus y1 squared. And again, the x2 minus x1 told us how far over, and the y2 minus y1 told us how far up or down. And effectively what we did was we turned this into a little right triangle. And that allowed us to find the length of that red segment, the one on an angle. Well, Pythagorean theorem is also going to be specific for right triangles, and it's going to allow us to find any one of those sides of the triangle as long as we know the other two. Okay? So the formulas are extremely closely related. Let's get into it. So Pythagorean theorem is used for right triangles, and we can only use it for right triangles. Our formula is a squared plus b squared equals c squared, and it is really important to know which is which. The super important one is c, right there, the hypotenuse of the triangle. So we have to know that language, hypotenuse. The hypotenuse is the longest side, and it is always opposite the right angle. So if we can find our little right angle, a right angle is indicated by the little box. I can draw an arrow out of the right angle, and it will point to C, or the hypotenuse. A and B, those are just the two legs of the triangle. So in a right triangle, we have a right angle, which points to the hypotenuse, which is C. And then the other two are called legs. Now, one of them is A, one of them is B, and it does not matter which. When we use Pythagorean theorem, the one you have to have in the correct spot is C. So let's see how this works using our a squared plus b squared equals c squared. In our example here, we know the two legs. They measure 3 and 4 units. Now that could be feet, miles, inches. It doesn't matter. But we know one is 3, one is 4 units, and the hypotenuse that we're looking for is c. So we're going to grab our formula for Pythagorean theorem, a squared plus b squared equals c squared. We're going to plug in a, plug in b, and plug in c. And then we're going to work it out. So c squared equals 25. But we want c. So remember, the opposite of squaring is to square root. And we can see that right here. We're going to take our c squared as 25. We're going to take the square root of both sides. And we're going to find out the value of c, in this case, is 5. So this is a 3, 4, 5 triangle. And that's going to come in really handy, 3, 4, 5. Let's look at another example. And in this example, we know the hypotenuse. The hypotenuse, as we can see coming out of that right angle, the hypotenuse is 10. And we know one of those legs. So we know the hypotenuse, one leg, and we're looking for the other. Again, a squared plus b squared equals c squared. This time we know c, so we are carefully going to plug it in where it belongs. The hypotenuse is the one we have to get correct. You can see as we work out our math, our final answer here is that missing side, whether we call it x or we call it b, its value is 6. Let me make that a little bit neater there. Its value is 6. So again, we can call it b because that's in the formula. We can put in x because that's the variable in the problem. Ultimately, we get that same result. Okay, so our sides here are 6, 8, and our hypotenuse is 10. So Pythagorean theorem. Now we should be able to work with fractions, decimals, integers, radicals. It doesn't matter. I mentioned the 3, 4, 5 thing is important. Here, I just want to mention to you guys the idea of a Pythagorean triple. So a Pythagorean triple is 3 whole numbers that work in the theorem. A squared plus b squared is plus c squared. 3 numbers for a, b, and c that satisfy that formula. And the least common multiple of that is called the family. So at the bottom here on the left, we have something called the 3, 4, 5 family. Multiples of 3, 4, 5 work. So 6, 8, and 10, as we just saw, is a Pythagorean triple that belongs to the 3, 4, 5 family. You don't have to memorize these, but the 2 most popular are 3, 4, 5 and 5, 12, 13. All right, well, let's just work out some of these. And, you're going to need your calculator handy for this stuff. So let's do 1 or 2. Let's see. Let's do problem. I'm going to make this a little bit bigger here. Let's do problem A. So we have a right triangle. We know 2 sides. We're looking for the third. That's the giveaway for Pythagorean theorem. Right triangle. I know 2 sides. I'm looking for the third side. So my formula we know is a squared plus b squared equals c squared. I have an a, I have a b, and I'm looking for c. So 9 squared plus 16 squared equals c squared. 9 squared is 81. 16 squared is 256, and that equals c squared. We're going to add that up, and we get 337 for c squared. And of course, we're going to take the square root because we don't want c squared, we want c. So c equals, and our directions here said to the 10th, so that's going to give me 18.4. C, or the hypotenuse, must be the longest side. So I already knew it had to be a number bigger than 16. If I don't get the largest number for the hypotenuse, well, then I made a mistake, and I have to fix that mistake. Let's take a look at another one, and let's look at D. Again, we have a right triangle. I need to identify the hypotenuse. That's my C. I have an A and I need B. And again, A and B can be switched. That doesn't matter. A squared plus B squared equals C squared. I have an 8 squared, B squared, 17 squared. 64, 17 squared. We grab our calculator. That's 289. Subtract 64 from both sides. B squared is 225. And now, of course, we want to square root. And we get B equals 15. So 15. Now again, since the hypotenuse was 17, that has to be the longest side of the triangle. I have to get a number smaller than 17. I did, so I can feel pretty good that I'm doing things correctly. Okay, well, let's look at some others. Here we have to do some radicals. And we did a lot of review of radicals at the beginning of the year. So we should be pretty strong here. So let's do an example. And again, we'll do A. Whoops, sorry about that. My screen. Okay. Try this again. A squared plus B squared equals C squared. I'm looking for C. A and B are interchangeable. So we have A squared plus B squared equals C squared. Well, the square root of 15 squared is 15. And the square root of 10 squared is 10. So that's 25 equals C squared. We take the square root and we find out C equals 5. So 5. Now, is 5 greater than square root of 15 and square root of 10? It is. If you put the square root of 15 into a calculator, you're going to get a number less than 5. But we have to be able to work in radical form. You cannot convert those numbers to a decimal, then work with them, and then be able to convert things back to radicals. You have to work in radical form. Let's take a look at another one. I'm going to choose C this time. And I'm just going to bring our work out here. So A squared plus B squared equals C squared. We have the hypotenuse, so I know C. So I'm going to say 6 square root 10, put parentheses around the whole thing. We're squaring the entire thing, plus B squared. And that equals 10 square root 6 squared. 6 square root of 10 squared. So remember, this is 6 root 10 times 6 root 10, which is 36 times 10, or 360. And this is why we reviewed radicals at the beginning. And 10 squared of 6 squared is 600. We're going to subtract 360 from both sides. B squared equals, so we have our 600 minus 360 for 240. Now, we can put that in the calculator, but it's not a perfect square. Since our directions say stay in radical form, and we are given radicals in the problem, we cannot punch that into a calculator and work it and get a decimal. We have to simplify this radical. So we're going to take the square root of both sides. B equals square root of 240. But now we have to work out that 240. So this goes back to all the times that we worked on our factor trees. So 240. That's a 2, 120, 260, 230, 215, 3, 5. I'm looking for my pairs. And I get 4 square root 15 for B. And that is the measurement of that side of the triangle, 4 square root 15. So we are going to have to be proficient with our radicals work to accomplish these types of problems. Okay. Let's stop there, and we're going to do more work with radicals throughout the year and with Pythagorean theorem throughout the year.